this morning and said, Psh, got it. Because homework, hopefully, at least that part of homework, was pretty easy. Now, before I even start writing down the answers, did any of you notice if you were checking your odds last night that every now and then you might have made a mistake on like whether it was a positive or whether it was a negative?
No.
It kind of depends. Like some people, you're like, nah, I aced them all. It was easy. But just a few of you, it's a very common mistake, especially in the beginning, to make mistakes on whether they're positives or negatives. So maybe on number 1, you were like, oh, I know it's a 1. I know it's a 2. Wait a minute. Why am I using 2 numbers? What are vertices? Is that ordered pair one, or is that x equals 1? Good, ordered pair one. So hopefully, did you guys write an ordered pair? Did you know you were filling in? So you could have done that for all of them. If you guys haven't or didn't get that far, at least we can write in ordered pairs for all of them, right? For 1 and 2 and 3 and 4. But then we were trying to plug in numbers. Now, most of you, did you figure out the 1 goes here and the 2 goes there? The question is, who's a positive, who's a negative? Both? Why, Caleb?
The one is opposite.
Good. The one on the outside is exactly how it looks. The one on the inside is opposite. That's a great way of remembering, and it'll always work. Now, hold on. What was the illustration I used yesterday for the whole inside-outside thing?
In and out.
In and out, right? Balboa and Lassen. And I zoomed in Google Earth, and then we went ahead and we're like, hey, there are people inside and there are people outside. The outside people are moving up and down, kind of, along the line. The inside people are moving back and forth, right?
Yeah.
Now, maybe you can draw some sort of, okay, I think I can remember this, because inside you're kind of looking at them backwards because you're here and they're facing, I don't know. I don't know if there's really a way to make that work. But it is going to work that the inside is always different than you think. Maybe you can think like the people on the outside you can fully see. It's like, oh, hey, it just is what it is. They are who they are. Got it. The inside people, I'm not really sure what they're doing. It's different than what you think. And guys, I'm using that right now to say what Caleb said is right, and it's perfect. The inside will always be opposite if it's a shift. But there's future stuff coming where the inside is also tricky, not just addition and subtraction. Anyway, that was good, Caleb. -1, -2. How many of you guys got it? Give me a quick, just hand all the way up. Be proud. Nice. Number 2. So use what Caleb said. The inside is always opposite. Maybe you got it right. Maybe you didn't, but maybe you think you can now. What's the x of the vertex going to be? +1. Is Andrew right? Yeah. So what's the y going to be?
4.
You guys are rocking it. So pause. I just want you to look at 3 and 4. Maybe you did it, maybe you didn't. Right now, double check your answer or write your answer now for 3 and 4, the vertices only. Ready, set, go. 3 and 4. Using 1 and 2 and what you now know the answers are. What would the vertices be for 3 and 4? Best guesses. Double checking your answers. You're writing them down for the first time. We're going to look at them in just a little bit of a cliffhanger, and we'll see how you guys did. Now, did anybody have time to check out the challenge? Didn't have to. Did anybody have time to check it out? What am I asking you to do? Or those people that were bored and just chilling saying, it's easy. What were they supposed to be trying to do? Yeah, let's read out loud. Adrian, what's it say? So yesterday, did we do something with graphics? The Post-its on your desk. Do you remember?
Yeah.
Okay, the Post-its on the desk that I had you guys use. What did I have you graph first? I said graph the following. The vertex, good. And how many more points? 2. Good, there were 3 total. I said graph this one, hey, he's the vertex, and graph these 2. And then I said make the whole parabola. But what did Jonathan? I heard the light bulb turn on. You were like, oh! How were you able to take those 3 and draw the whole parabola?
Oh, I copied all of this.
Good, because every parabola, remember, has symmetry. I know that calculus kids are being silly this morning with their donuts and their coffee. But, so you graphed kind of like these 3 points, and then Jonathan saying just copy it on the other side, because the parabola wasn't there. A lot of you just had, if you did it, those 3 points. You're like, ah. Until you realize this guy's the vertex, so he's the bottom. Forget this dude. And as Jonathan said, we can always copy on the other side. Copy on the other side, and then, so, in our notes yesterday, I know it was a little rushed at the end of the class, but we're going to practice it some more today. We were talking about, okay, what if you have the equation, not 3 points, but you have the equation. How do you graph? Does anyone remember the very first step? If we need to graph from an equation like the challenge is saying. Good. Do you guys hear Isaiah? He said graph the, you just found the most important point, graph him. So ready, set, pause. Let's just make sure graphing points can get a little tricky. Are you moving right when you're supposed to, or left, or up, or down? Can you graph 1 and 2's just the vertex? Graph the point for the vertex on 1 and 2. Those of you that already tried the challenge, you're just checking. Those of you guys that didn't, I think you can do it now. So graph the vertex for number 1, just the point. Graph the vertex for number 2. Okay, help me out on number 1. That -1, what movement is that telling me? From the origin, left,
1.
Good. And then that -2 is telling me move left 1 and then move. Okay, so are we rocking it?
Yeah.
Okay. No, that's too hard. Let's just wait. Number 2. Movement from the origin.
Right.
Right 1?
Up 1.
Up 1. Perfect. Guess they'll all be computer programmers. Remember I said yesterday, computer programming starts with just being able to describe movement and motion and change. A lot more to it, but that's the beginning. Okay. I am going to ask a really hard question, but I think maybe some of you could get it. With only having the vertex in number 1 and only having the vertex in number 2 shown, but looking at the equation in the beginning, for both, can you tell if this parabola is going to be going up or going down? Just with the vertex, no other point, and the beginning equation. Max, what do you think for number 1?
Down.
Yes. Why? Yeah, remember, maybe you do, maybe you don't. But last semester, if someone's negative, they're probably, well, there are some really negative, like, smiling people, and you're like, oh, you're a jerk, because they're just, like, making jokes against everyone all the time. But, in general, you can think negative being like, those kinds of people, they're going to be frowning more. Yeah, sure, why not? Negative, I know, his shape, even only having 1 point. However, number 2, how is he facing?
Positive.
Yeah, positive, right? So we'll say happy, so he's concave up. Okay, we know the general picture. We know 1 point, so what do? Just like swoop it and say,
No.
I'll fake it. No, let's not fake it. After we graph the vertex, even after we know the general shape from the equation, to graph it, did you guys look at those steps from yesterday? When you were trying to graph last night? Graph the vertex was step number 1, but what were you supposed to do next?
Let's describe.
Describe was part of homework, that's good, but actually, just to get the graph, do we need to go back and look at notes? It was quick, it was at the end of yesterday. What was next after the vertex? Okay. Yeah, plug in. Hold on, let's go look at it, because not all of us are on the same page. Plot the vertex, have we done it?
Yes.
Yes, but from the vertex, go 1 to the right, plug in, find the point. Go 2 to the right, plug in, find the point. And once we yesterday plugged in one guy and got his point, remember we have to plug into the equation, plugged in the next guy and found his point, then we were able to graph those 2 points up here in our parabola. And once we have 1, 2, 3, just like Jonathan said, copy, swoop, there he is. So for our examples, you guys still have your worksheet out, right? For our examples, what are we plugging in to go 1 to the right of this vertex? Well, 1 would be 2 to the right, which we could do that. But just so that we all are doing the same thing, 1 to the right would be what x value?
0.
0. And then 2 to the right would be, okay, so we're going to plug in 0 and figure out what's going on. And we're going to plug in 1. Now, technically, there's a really snazzy way of doing this. The really snazzy way of doing this is our function notation that says, hey, put in 0. We actually don't even, remember how mathematicians are lazy? We don't need to write this. We could have actually just shortcutted it. We could have just said, hey, we're trying to find what's going on at 0. That's a shortcut because I'm saying x is 0, go plug it in. And I'm trying to find f of 1. What's going on at 1, go plug it in. Remember the goal. We're trying to figure out when I'm at the 0 line for x, where's the y? Is he here? Is he here? Is he here? Is it going to be like a really wide parabola? Is it going to be a really tall parabola? I don't know until I get some points. So pause. Just making sure we have the idea, because it gets kind of sticky when we have to do PEMDAS and plug in. What am I going to plug in here to get my other? Oops, I started plugging in 0. Hopefully you guys look at the picture and say 0 is wrong. What would I be plugging in to go 1 to the right this time?
2.
See it? Let's plug in 2. And how about if I'm going 2 to the right?
3.
Got it. How are we doing? Okay. You know what we're trying to do? We're trying to get a parabola. But we don't want to do 5 points. Let's do the 3 points and do the copy thing from yesterday. But we only have 1 so far. We've got to go look for others next. I went to where my vertex was, and I just said, hey, get 1 to the right, which is at x equals 2, and get 2 to the right, x equals 3. I just want a couple so I can copy and have a nice picture.
Okay.
Does that make sense?
Yeah.
Yeah. And I didn't want to use like 0 and 1 because I already have this guy. So I need to start here, start somewhere new, and then make one. Okay. Plugging in. Did anybody make any mistakes on plugging in last night? Maybe you found them, maybe you didn't. It's tricky. I'm not going to necessarily plug in all of these points and take tons of time to do it, but we at least know where to plug in the 0, right guys?
Yes.
Because it's in the x spot. The tricky part isn't so much usually where to put the x, it's what to do next and to do it perfectly. Right? Because math can make one mistake and it messes everything up. So PEMDAS, just remind me real fast, because we did it really quickly yesterday. I didn't really get to slow down. Parentheses first. So 0 plus 1?
1.
What's next? Exponent. So then what's 1 squared?
1.
1. So why am I still writing this?
0.
I've only done the exponent. Who's still there?
-3.
Now I'm allowed to subtract. Got it. You gotta be really careful with your negatives and positives, but we figure out that when x is 0, y is -3. Remember, this is just a snazzy way of saying y equals. So, when I go to 0, I'm not going up at all. I'm going down to -1, -2, -3. Oh, that makes sense. It's going to go down. It needs to go down. You guys see it?
Yeah.
So when x is 0, I figured out where my y is. Everybody got the point okay?
Mm-hmm.
Cool. Now, wait a minute. Actually, we can be cool and say, hey, 2 birds, 1 stone. We have 1 point, but we get 2 points. Why? If you want, Jonathan, right now, you can copy it and be like, you're welcome. So 1 plug in, 2 points. That's cool. But then to get a full picture, because some of you would like connect this going like this, some of you would connect this going like this. Like you still don't totally know because it's so close to the vertex. That's why we do 1 more, just to have a clear picture. So we're going to do the exact same PEMDAS, starting with parentheses, 1 plus 1 squared. Remember, we have to use the pattern. That's all functions are. They're just patterns. They're just telling us like a legal progression or what needs to happen. I need to move 1 right. I need to square. I need to make that a negative and then subtract 2. They're just telling me what needs to happen. So if you do the PEMDAS, inside 2 with a squared. If you do the exponents, that's going to be a 4 with the negative. Has anybody beat me? What'd you get for your y value? Got it. So f of 1 when x is 1, I'm going down, 3, 4, 5, 6. Ooh, this is a steep guy. But remember, 1 point. It's a 2 for 1. It's a token. Find 1. Get in. There we go. Perfect. Can you guys try to graph number 2 now? We already have the vertex. We already talked about 1 to the right, 2 to the right. All you have to do is plug in, get y values, and then copy it. So use what we did. Try to get number 2's graph. This is technically solidifying the skills from yesterday's homework.
Did you work on it? Okay.
Got it. It looks weird. I just want to show you. Are we doing plugging in?
Yeah.
Yeah. Come on. I think this was the hardest part of homework, guys, was getting the graphs. That's why I'm just letting us, we need to use it for today. I'm just letting us practice and letting us ask questions, right? You know what I would say too, is we were at 1 and 1. So now we have to say, we don't know that is 1. We can go to x equals 2. Where do you go? Take the 2. Remember, if it's in x. Ooh. So it seems you still wrote the x, it's substitution. But instead of writing x is kind of out of the game. And then down here, instead of 2. Good, thanks, sister. Just 1. You're going to check your PEMDAS. Step by step. Okay, guys, it's so easy to mess up PEMDAS, so I'm going to double check and make sure that we're doing PEMDAS correctly, okay? So hopefully you guys put the 2 in the x spot. Hopefully you did parentheses next. Exponents next. Is anybody able to mental math this real quick and be like, it's 3?
Yeah, why did you put 2 in the exponent?
In the exponent, because it was.
Oh.
You see it?
Yeah.
Yeah. But I put the 2 in the x spot because that was the x1 to the right. I just starting from the vertex and then plugging in. Does that make sense? So if you guys did your PEMDAS correctly, sorry, I did it kind of quick, but parentheses first, then the exponents, then the multiply, then the add, but most kids can kind of see the 3 right now, 2 times 1 plus 1. So I know when x is 2, I'm going to 1, 2, and 3. And I can copy that. 1 to the right can also go 1 to the left because of that symmetry of parabolas. Yeah. Oh, because my y value is a positive 3. So then when my x is 2, that's the number I plugged in, my y is 1, 2, 3. Okay. Andrew.
How'd you get 3?
Oh, because the next step in PEMDAS, so far so good. The next step in PEMDAS would be multiply. 2 times 1 is 2. Then add plus 1. You added them, yeah, you just switched your PEMDAS. Does that make sense?
Yeah.
Yeah. I know, it's so easy to get that messed up. This next one I'm going to have to do the exact same function because I'm plugging into the exact same place, but this time the 3 goes in instead because I want to know when x equals 1, 2, 3, what's my y value? Can I just say a step of PEMDAS and you tell me what happens there? Ready? Parentheses. What happens when I do parentheses? Good. Parentheses, there's a 2. Exponents, there's a 4. Multiply, there's an 8. Add, there's 9. You guys got it?
Yeah.
Cool. Yes. So when I have 3, then I can go ahead and do 1, 2, I think this is 10. Is it 10? Did you guys figure that out? Okay, so it's minus 1. And then I can go 2 to the left. So there it is.
Transformation, just the explanation. Okay.
Technically our goal today, because you can see this is 8.4b, there's like another homework of different problems that you didn't see last night. But it's still 8.4. So is it still important to be able to find a vertex? Yeah. Because sometimes you're going to be graphing, and that's the first step, is knowing the vertex. It is still going to be important to graph sometimes, but if you guys look on the back of your paper, there are only 4 graphs in homework. Last night I think there were 6. But we are going to be graphing, so we went ahead and reviewed the PEMDAS, reviewed the plugging in, reviewed how we get 1 point to the right, 2 points to the right, and then we copy and say, we're done. But today we're going to be working just a little bit more on describing. And have you guys noticed there's a certain part in both numbers 1 and 2, and I'm not meaning the blank, because the blank we haven't touched, but there's something else we haven't even looked at. Did anybody figure out what we haven't looked at yet? Yeah. There's this whole extra new guy. This is what today's lesson is supposed to be about. There's this whole extra new guy that looks way different than anything that we saw last night. Well, maybe not way different. Is there something happening on the outside of something? Yeah. Is there something happening on the inside of something? Yeah. So Isaiah, even though you're right, we are going to be describing the transformation. Here's the trick. What's new is we're not describing the transformation that happened from like a good old-fashioned x squared to get here. We're talking about the transformation that's going to occur for the next. Oh, okay. Does that make sense? Yeah. Okay. Kiddos, you've been sitting for a little bit. I have a new seating chart anyway. Let's go ahead and pause on this. Get all of your stuff in one nice little stack. We're going to change seats. Talk about 8.4b to finish this worksheet. And then we might actually end up grading both homeworks tomorrow because I think some of you just figured out how to do last night's homework. Yeah. Let's freeze. You guys getting all your stuff in one nice little stack? Okay. Now, nobody move until we figure out where we're moving to. Otherwise, we're just going to be like moving off and chilling and standing and not doing anything. Okay, now listen. This seating chart is not necessarily set in stone. If you guys remember last semester, I made a few changes in the midst. I might do that again. But we're just going to try it out. We'll see. Ready? Stop. Look. This is the back of the room. So, check it. Hannah's seat. You guys see where Hannah is right now? Everest is going in Hannah's seat. Adrian's going to be next, then Andrew, then Max, and those are those 4 seats in the very far back. Okay? But Diana, to help us, can you actually push the seat right behind you all the way to the back? It's kind of like in a weird spot. Just to help us. You're not sitting there, but that's where Andrew's sitting. Okay. And then there's space. And then, Caleb, you're in the far left corner where Sunny is right now. Andreas, you're in the far right corner where Armando is right now. Are we kind of, Andreas isn't here today. Brooke, you're where Isaiah is. Sunny, you're up here in the front where Andrew is. Do we kind of see? This is the front of the room, back of the room. Go. Out here, out here.
Isaiah.
Fabulous kids coming early on Wednesday.
Not that far from each other.
Some of this is trying to make sure you can see the board. Some of this is I think you could work really well with the people in your new group. Some of this is I think you'll be less distracted if you're a certain place.
Oh, from the sun again.
Yeah, you're in the fourth. Okay. I don't know about you guys, it's warm in here. Let me pop open the door. Yeah. But as you guys are finding your seat, I'm going to go ahead and have you open up your notes. Keep that 8.4 sheet out. We're not done with 8.4. We're not going to 8.5. So you can pick up right where we left off yesterday. I want you to write this little piece down. Super important for today. Some of it's new, to be honest. Some of it's kind of just review. Keep that sheet out, though. Keep our practice page. We're going to be using that for examples today. You guys have seen a new system, kind of, right? You don't have to write down as many examples because I have a nice page for us to work from. So keep that out. We're going to keep working on it. But open up notes now that you're settled in your new seat, at least your new seat for right now. I'm going to get some cool air in here. As you guys are writing this down, for just a couple of you I have in very, very, very particular seats. I have a reason for almost everyone in almost every seat that you're in. Maybe not the seat, but the people that are around you, the general portion of the room. I kind of want everyone to get to a new spot because most of you were kind of tired of your old spot. Or at least you've been there for a long time. So I'm going to come around and explain just a few of the seats that I made. But please, if you have any questions or if you can't see really well for today, let's just leave it. For today, let's just leave it. But come talk to me or talk to me right after class, and then I can make adjustments. Okay, it isn't like a set in stone, it's just a practice. Okay. So notes open, right where we left off yesterday. You're just writing down basically this one page. It's pretty much just this one page. We have a new goal. Describe, then graph. Transformations to f of x. Let me make the notes bigger because right now everything's all squished because I had the seating chart up. Oh man, well that's a little intense. Do you guys see anything that kind of looks like yesterday?
Yeah, the inside outside.
Yeah, the inside outside, which is actually super cool. Okay, let me try to put light because I don't know, back there the sun's shining in during period 2, so you guys get hot and there's like a glare on the screen. There's all sorts of stuff that isn't the best. But inside outside. I'm going to actually go ahead and move this goal down just a little bit so that we can see everything a little bit clearer. Because our goal, very similar to yesterday, just a little bit different. Our goal is to describe, oh hey, don't we have blanks on our worksheet that still need filling out? Describe, because if you guys read the directions, you're supposed to describe what changed. You're supposed to describe the transformation. So I just put a blank so we can try to describe the transformation. Now hold on, don't fill it out yet, because here's the weird thing with today. The graph that we just drew is not the transformation. I mean, it is. It is. Yesterday, we did talk about how any parabola in what we call vertex form is technically moving and changing a basic parabola, an x squared or an ax squared. We talked about how any vertex form is actually moving the vertex horizontally with that inside h or vertically with that outside k. We talked about that, but today, if you notice, or actually look at your worksheet, we're starting with the vertex form. We had to graph the vertex form, but then if you guys look, there's that extra equation, and I think, at least in the worksheet, aren't they all called h? Okay. In homework, they might be called g, they might be called other letters. It doesn't really matter. There's somebody else. So up here, I have, okay, you have an f, but you have this new guy. And if you guys want, in your notes, you could actually change this to be like your worksheet. You could make it an h. I don't know. You can, in homework, it'll be a G. On your worksheet, it's an H. It's another guy. And the other guy says, okay, I'm taking that guy. I'm taking the graph that you have, and I'm changing him. How is he changing? Well, inside, guess what? We can still use Caleb's trick. Oh, Caleb, all right. You moved. Caleb's trick of the inside being opposite. We can still use that. The inside, I'm going to have a shift if there's a minus or a plus. The outside, I'm going to have a shift, but just what you see, no opposite weirdness. Up or down. Wait, do you guys see what I'm telling you down here? I'm telling you how to transform. So just a second ago, Isaiah was like, oh, you just fill in the transformations. No big deal. Okay, pause. Look at number 1. Okay, look at number 1. Look at the H guy. Look at the second guy, the one we were ignoring all this time. What's happened? What's changed? Is there an A that's new? Is there an H that's new? Is there a K that's new? Who do we have? An A or an H or a K? And number 1 in the H. Good, we have a K. Do you see it? Okay. Now, come down here and say, okay, well, wait a minute. What happens if that K guy is there? It's a shift up or down. Do you see it? Now, specifically, is it going to be, according to yours, since there's a plus 4, is it going to be a shift up or a shift down? Yeah, because it's exactly what you expect. Now, if it was on the inside, wait a minute, 1, 2, 3, and 4, are there any inside changes? There's a K in number 1. Is there anybody who has an H? Let me pull it up on the screen because I think some of you guys don't know where you're looking. You're looking in your worksheet. You're looking on 1 and 2, or at 1 and 2 and 3 and 4. We just figured out that this guy has an outside change, and I think, Jerry, you were the one that said it clearest. It's a shift up 4. He's totally right. We can fill that in. It's a shift up 4. We're taking the graph that you have currently on your, supposed to have on your worksheet, and we're going to be moving him up 4. But number 2, who's that? Is that an H? Is that a K? Is that an A? We better go back to that page.
H.
Yeah, good. It's an H. It's an inside change. And inside changes are right or left. Maybe it might be helpful for some of you to actually write some of these down as far as like, okay, whenever I have an inside change, sorry, I use clicks. I don't know if you guys don't use it as much. Whenever there's an inside change, it's right or left. Whenever there's an outside change, it's up or down. This one's technically an outside, but this is an outside with a times, not a plus or minus, but a times. But on number 2, we have an inside change. So how am I going to fill in that transformation blank over here, guys? Good. Oh, wait a minute, though. Is it an up if it's inside? It was up when it's outside. I'm just rewriting it in red. But what is it if it's inside?
8, 5. No, 5.
It's 5. It's opposite what you think, but is that going to be moving to the inside, right or the left?
Outside.
Hold on. It's okay. Get your bearings. You're inside, in and out. You're not outside, so you're not moving up and down. You're moving back and forth, and it's shift
Left.
backwards what you think.
Right. Yeah.
So left would be like a minus, but it's backwards what you think, so you're actually going right. You switch the sign. So thinking about what Caleb told us earlier, the inside, you shift the sign. So you see a minus. So those of you guys that thought left, you at least got the right movement. You're moving horizontally. You just forgot, oh wait, the minus, I'm thinking a plus. I'm actually going to the right, not to the left. Why am I saying that? A number line. A number line. Where are the negatives? That way. Where are the positives? That way. So I see a minus and I go to the right. Does that make sense? Opposite. Yeah. Yeah. So can we, or do you have this in your notes, because it's going to be pretty important, right? Because you can actually look at any of these H's or G's or whatever they call them, and you can say, okay, is it inside or is it outside? Inside, right, left, outside, up, down. We just got to figure out the signs like we kind of got stuck on last night, but hopefully we practice them. What do you guys think on 3 and 4? What's different on 3 and 4? One has a fraction, and actually, hold on. They're not H's or K's. They're A's. Yeah, so if we go back to our notes really quickly, okay, wait a minute. The A, we're stretching or shrinking. So whenever we have multiplication, and technically, you guys want to think about it, it's outside multiplication. So it's vertical stretching and compressing. Inside would be the other way. But we have the outside stretching or shrinking. The nice thing is, it's not inside. It's not where everything, we can't quite tell what's going on. It's exactly what it looks like. So if it's 2 times, guess what? It's going to be a vertical, yeah, let's put that. A vertical stretch. Why am I stretching? Well, because I'm multiplying everything by 2. You guys see how I'm just using the wording from the notes?
Yeah.
Just use the wording from the notes. So then what's going to be this one down here? Vertical? Shrink.
Shrink. Vertical.
Yeah, does that make sense? I mean, you could say compress. Compress is a snazzy way of saying shrink. But either way, vertical shrink times 1/3. Now, we've already graphed these guys, right? For numbers 1 and 2. Did we finish graphing 3 and 4? No. But we did graph 1 and 2. For 1 and 2, for instance, for number 1, we figured out the vertex is at -1, -2. And then we were able to go 1 to the right, and we figured out, I think that was -3, and then this one was like -6, 4, 5, 6. Right, and we copied it. In homework, when they say to graph, and remember, I have empty graphs on the back of the paper, that way you guys can try to do that. In homework, when they say to graph, I need you to graph the F or the original guy first. Because you need to take him and change him for the second one. Okay? So the point is actually graphing H. It's not graphing F. So to graph H, we have to say, wait a minute, you're based on that guy. So start here, review the skills from last night, get his graph like we did in class. Now, how are we going to shift this guy up 4? Easy. How are we going to shift him up by 4? Easy. We're going to go ahead and say, okay, how do we graph? If you want to write it down, you can, but check it. Isn't this what we just went over at the beginning of class about do the vertex, go 1 to the right, 2 to the right, copy? That's just yesterday. What's new? What's extra? Change it. Point by point using whatever you filled in the transformation blank with. So on number 1, what are we supposed to do to every single point?
Shift up 4.
Easy. Vertical shift up 4. So I'm going to go ahead and keep that page so you guys can see it. But I'm going to go ahead and take that number 1 that you guys already have graphs for. We're just going to take every single one and say up 4. Sweet. Now, if I were you, I would use 2 different colors in homework to make it easy. So you can have your beginning one and then say, or make it dotted. You can do that too. And then say, okay, up 1, 2, 3, and 4. Up 1, 2, 3, and 4. Oh, my point was too squished. I'm supposed to be over. 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. See what I'm doing? That's it. 1, 2, 3, and 4. 1, 2, 3. Got him. I just went up over every single point. Okay, and here's the deal. We got through, in some senses, 1 and 2 and 3 and 4. But what do you guys notice in the very bottom of the sheet? 5 and 6, right? Do we even talk about 5 and 6? No. Okay. So 5 and 6 tonight are like the challenge problems, meaning this part of homework for tonight is optional. Okay? We didn't get to examples like that. So the main part of homework that I want you guys to do, the only homework I'm checking tomorrow, is 8.4a from last night and 45 to 52. Sound good? All right, bye guys. I'll see you later. We're not calling them by homework numbers anymore. It's just 8.4a and 8.4b. Those are their names. Don't worry about the front.
I literally can't hear you. I'm serious.